Good day students, welcome to Mathgotserved.com. In this clip we're going to be going over how to convert between scientific and standard notations. This standard is covered in pre-algebra, algebra 1, and in science courses. Don't forget there are 12 practice problems at the end of this presentation that you can go through in order to demonstrate your mastery of the concept that we covered in this video presentation. If you'd like to gain access to the entire playlist, valuable course information, and other worksheets, you can visit our website at Mathgotserved.com or take a look at the link in the description below. Alright, the instructions for the examples that we're going to be working on is as follows. We are to convert the following numbers to scientific notation. Okay, so they are in standard notation. We're going to be converting them to scientific notation. Alright, question number 1. Let's say we have the number 75,000. So the goal here is to convert it into scientific notation. Okay, so we have 75,000. Now to convert it into scientific notation is we need to have a digit between 1 and 9 in front of the decimal point, and then the digits go after that, and you have that number multiplied by a power of 10. Okay, alright, so let's go ahead and express this number in scientific notation. Now what you need to remember is that if you're going to the front of the number, you're going to be adding to the power of 10, and if you're going to the back, you're going to be subtracting. Alright, so this is the front of the number. Let's call this the front. The front is going to be positive direction. This is the front right here, and then the back of the number, let's call that B, that would be the negative direction. Okay, alright, so the decimal point will start right here. If there's no decimal point in a number, it automatically falls behind the last digit, and the digit in the ones place. So you have your decimal point right here. So the goal is to ensure that there's only one digit to the left of the decimal point. Alright, so our goal is to move the decimal point from this position all the way to the position behind the first digit, which is 7. Okay, so our first digit is 7, and we need to move the decimal point behind it. So the question is, how many moves of our decimal point will take the decimal point right here to our target, the position right behind the 7th digit? Let's go ahead and do it. So we're going to move the decimal point 1, 2, 3, 4. Voila, that's exactly what we want. So 4 moves will take us to where we want. Okay, so remember, we're moving forward, we're moving to the front, so it's going to be positive 4. We're going to be multiplying the number by 10 raised to the positive 4 power. Okay, so 7,500 is going to become 7.5. Since we moved the decimal point 4 places to the left to achieve this form, we have to multiply by 10 to the positive 4 power to compensate for the movement of the decimal point. Okay, so there goes your final answer for question number 1. Alright, let's take a look at another example, question 2. Let's say we have the number 9,730,000. Okay, so the goal is to convert this number into scientific notation. So let's go ahead and do that. Alright, so we have 9,730,000. Now the decimal point is right here behind the digit in the ones place if it's not specified. And then we remember that if we're moving our decimal points to the front of the number in order to achieve only one digit to the left of the decimal point, that will be a positive move. Okay, to the front is positive, and then if we're moving it to the back of number to achieve our desired form, that will be a negative move. Alright? So in this particular case, our target is to make the decimal point to end up right behind the first digit. Okay? The first digit is 9, so we need the decimal point right here. Okay? Alright, so the question is how many moves and in what direction will take the decimal point from this position behind the ones place all the way behind the 9. It's going to be a forward move, clearly, but how many times are we going to have to move it? Well, let's see. We're going to move it 1, 2, 3, 4, 5, 6. Voila. So 6 moves in the forward direction will take our decimal point to the desired target. Okay, so because of this move, we're going to be multiplying by 10 to the what? Since we move to the front 6 times, it's going to be 10 to the positive 6. Okay, so 9,730,000 is the same thing as 9.73. And to reflect the move of our decimal point, we're going to have to multiply by 10 raised to the positive 6 power. Alrighty, so that's the answer to question number 2. Alright, let's take a look at the next one, question 3. What if we have 79 for question 3, 79.32. Alright, we want to convert this into scientific notation. How do we do this? So we have 79.32. So our first digit is 7. So we need to move our decimal point from this position right here to this position. So that will be a move 1 place to the front, which is a positive direction. So just move it 1 place to the front, and that will take it right here. Alright? So 79.32 is the same thing as 7.932. Now since we moved it 1 place to the front, that would just simply be 10 to the 1 power. Okay, so it will be 7.932 times 10 to the first power, and that, ladies and gentlemen, will be our final result. Alright, let's take a look at number 4. Now in the previous problems, we've been taking a look at numbers that are bigger than 1. Okay, now how about we take a look at numbers that are smaller than 1, fractional numbers. So let's say we have 0.28. Okay, what if we want to convert this into scientific notation? Let's take a look at how to attack problems of this nature. So if you have 0.28, remember your positioning. The front of the number is positive. So if you're moving a decimal point in that direction, is positive, and the back of the number is negative. So the desired goal is to move the decimal point to the right of the first digit, okay? So this is the first digit right here. So our goal is we want the decimal point to end up right behind the first digit. That's our target. So how many places and in what direction do we move the decimal points to achieve that form? We're going to move it 1 place to the back, okay? 1 place to the back will take us there. So this number is the same thing as 2.8 times what? Times 10 raised to the, now since we moved the decimal point towards the back 1 place, is going to be times 10 raised to the negative 1. Okay? So it's 2.8 times 10 raised to the negative 1 is the way to write 0.28 in scientific notation. Alright, let's take a look at another number like that, question number 5, another number that's a fractional number. What if we have 0.0000000 0.0392. Alright, so let's try this one out. Our solution is as follows. So we have 0.0000000 0392. Alright, so we want to convert this number into scientific notation. This is the back of the number, which indicates negative movement. This is the front, which is positive, okay? So we need to move our decimal point from this position to the right of the first digit. So the first digit is 3. So we need our decimal point right here, okay, right behind 3. So how many places do we have to move and in what direction to get the decimal points to the right of 3? Well, let's do it. So we're going to have 1, 2, 3, 4, 5, 6, 7, one more, and 8. Bam! That's what we want, okay? So 0.000000392 is the same thing as 3.92 times 10. Now, since we moved the decimal point, how many places do we move it again? 8 places to the back of the number is going to be times 10 raised to the negative 8. Okay? So this would be times 10 raised to the negative 8 because we moved the decimal point towards the back of the number. And that's the answer to question number 5. Okay, let's take a look at the next one, number 6. We're going to do another fractional number. So for number 6, what if we have the number 0.00811? Now, how do we write this in scientific notation? Alright, so we have 0.00811. We know where the front is and the back. So this is the front, which indicates positive move. And this is the back side, which indicates a negative move. Alright, so target is the first digit, which is 8. We want our decimal point behind the first digit. We want our decimal point right here. Okay, so how many places and in what direction do we move the decimal point to achieve that? We're going to move it to the back, okay? How many places? 1, 2, 3. So moving the decimal point 3 places to the back is the same thing as multiplying by 10 raised to the negative 3, since back direction is negative. So 0.00811 is the same thing as 8.11 times 10 raised to the negative 3 to indicate that we move the decimal point 3 places in the backwards direction. Okay, so there goes the answer to question number 6. Okay, so far we've been going over how to go from standard notation to scientific notation. Now, how do we do the reverse? Alright, 7 to 12 will help us with that. So the task now is to convert the following numbers from scientific to standard notation. Okay, from scientific to standard notation. Alright, so to get us started, we have, for number 7, what if we have 5.01 multiplied by 10 to the 4th power? How do we change these to standard notation? Okay, so to do this, we just have to remember the directions of our move and what standard notation is. So we have 5.01 times 10 raised to the 4th. Now, this 10 raised to the 4th is a component of scientific notation. You don't have any number multiplied by 10 to a power in standard notation. So we need this gone. We need to get rid of 10 to the 4th power. It's an annoyance. It's in the way. So how do we do that? Alright, so you bring down the number that you're multiplying 10 to the power by, so bring down 5.01, and you ask yourself, how many times do I have to move this decimal point in order to get rid of this 10 to the 4th? Well, this is 10 to the positive 4. How do you get rid of positive 4? The opposite of positive 4 is negative 4, so if you subtract 4, that will get rid of 10. Okay, so subtract 4 basically means that you're going to be moving to the back direction how many times? 4 times in order to get rid of this positive 4 here. Alright, so we're going to move 1, oopsie, let's try that again. We're going to move the decimal point 1, 2, 3, 4. Voila, that's what we want. And then we're going to insert the zeros there. So it's basically going to be 5.01 times 10 to the 4 is equal to 50100. 50,100. That's the answer. Because when we move the decimal point 4 places to the back or minus, this is cancelled out, gone, goodbye, and then you just move the decimal point here to get 50100. Okay, so that's how you do it. Now let's take a look at number 8. We have this number in scientific notation. Number 8, what if we have 3.7 times 10 raised to the 6th power? Alright, so I want to write this in standard notation. Alright, so to accomplish this, we need this 10 to the 6th, positive 6 gone. So how do we do that? You do the opposite move, right? So this is positive 6. To get rid of positive 6, you have to subtract 6. So what does that tell you? It tells you you're going to be moving to the back 6 places. Okay? So we have the number, bring down the actual number, 3.7, the number between 0 and 10, 3.7. Okay, now since we are subtracting 6 from the power, that means we're going to move negative 6. So we're going to move it to the back. Okay, so remember the back side is negative. So we're going to move it how many times? 6 units. So it's going to go, we're going to go 1, 2, 3, 4, 5, 6. There you have it. So 0, 0, 0, 0, 0. Okay, so 3.76, 3.7 times 10 to the 6 is the same thing as 3, 7, and then we have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. So that is 3,700,000. That's the answer to question number 8. Alright, let's take a look at another example, question number 9. So for question number 9, let's say we have the number in scientific notation. We have 8.35 times 10 raised to the 3rd power. Alright, so the goal here is to write this number, which is in scientific notation. We're to convert it into standard notation. Okay, so how do we do that? We need to get rid of this 10 to the 3rd power right here, okay? So 10 to the positive 3. In order to get rid of positive 3, we need to use the inverse, which is minus 3, which basically indicates we're going to be moving the decimal points to the back 3 places. Okay, so bring down this digit part between the number between 10 and 0, 8.35. And then let's apply the move. We're moving it 3 places to the back, so we're going to move it 1, 2, 3 right here. So that means we're going to insert a 0. So that move will eliminate that 10 component. And then our final answer, 8.35 times 10 to the 3rd is the same thing as 8,350. Move the decimal points 3 places to the back, and that will be your desired result. Okay, let's take a look at number 10. What if we have a situation where the power of 10 is negative? So number 10, what if we have 7.4 times 10 raised to the negative 1? How do we write this number that is in scientific notation? How do we write it in standard notation? 7.4 times 10 to the negative 1. We need to get rid of this negative 1 here. We need to cancel that out. So you have 10 to the 0th power, which is just 1. So the opposite of minus 1 is what? Plus 1, which indicates a move to the right 1 place. Okay, so bring down the number, the digit part, 7.4. Our decimal point will be moving where? It's going to move 1 place to the front. Remember, the front is what? Positive, and the back is negative. So 1 place to the front, and that will get rid of this 10 piece that we have here. So 7.4 times 10 raised to the negative 1 is the same thing as 0.74. Alrighty, so there goes the answer to question number 10. Alright, let's try another problem similar to that. Number 11, what if we have 2.6 times 10 raised to the negative 6 power? How do we write this in standard notation? As we can clearly see, this is in scientific notation. So 2.6 times 10 raised to the negative 6. We need to get rid of this 10 to the negative 6, okay? So negative 6, we're going to apply the inverse operation. So the opposite of minus 6 is plus 6. So that means our decimal point is going to be moving to the front of the number 6 places in the front direction. Okay, so bring down the digit component 2.6 and let's apply the move. We're going to go 1, 2, 3, 4, 5, 6. Alright, right there. So you insert the zeros in every spot. Okay, so we had 1, 2, 3, 4, 5, 6. There you have it. So that will get rid of this 10 to the power of negative 6 component that we have there. Okay, so 2.6 times 10 raised to the negative 6 is the same thing as 0 point, how many zeros do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 2, 6. And that, ladies and gentlemen, is the answer to question number 11. Let's take a look at one more example. What if we have for number 12? What if we have 9.51 times 10 raised to the negative 3 power? Alright, let's do it. So to do this one right here, we want to write this number that's in scientific notation. We want to write it in standard notation. Okay, so this 10 to the negative 3 has to go. Goodbye. How do we get rid of it? We have minus 3, so we're going to use the inverse operation. Plus 3 will result in this number being raised to the 0th power, which make it 1. Okay, so since we have plus 3, let me change my color scheme here. Since we have plus 3, that tells us that we're going to be moving our decimal point 3 places to the front of the number. Okay, so we have 9.51, bring that number down, the digit part. And we're going to move our decimal points 3 places towards the front. Remember, the front is positive direction and the back is negative. Okay, so let's do the move. We're going to have 1, 2, 3 right there. Okay, and then insert the zeros, 2 zeros. So the final answer, 9.51 times 10 raised to the negative 3 power, is the same thing as 0.00951. Ladies and gentlemen, that's the answer to question 12. Now it's your turn to demonstrate mastery. We're going to give you 12 problems to work on, and then you can take a look at what the answers are. Alrighty, so here are the 12 practice problems we talked about at the beginning of this presentation. What we'd like you to do at this time is pause this video and answer these questions. 1 to 6 convert to scientific notation, 7 to 12 convert to standard notation. When you're done solving all 12 problems, click on the playback button and then you are going to see what the answers are. Alrighty, welcome back. Hopefully you had a chance to try out the problems. These are the answers to questions 1 to 12. So for number 1, the answer is 3.5 times 10 to the 4th power. Number 2 is 8.94 times 10 raised to the 6th power. Number 3 is 8.181 times 10 to the 1st power. Number 4 is 9.3 times 10 raised to the negative 1. Number 5 is 5.32 times 10 raised to the negative 9. And number 6 is 7.36 times 10 raised to the negative 2 power. Okay. Number 7 is 5,060. Number 8 is 8,400,000. Number 9 is 23,100. Number 10 is 0.39. Number 11 is 0.000. 4 zeros, 3, 1. And then number 12 is 0.0765. Okay, so how well did you do in these 12 practice problems? Let us know in the comment section below. If there are any problems you'd like us to clarify further, just let us know what it is, what the problem is in the comment section below, and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of scientific notation and exponents, do give us a thumbs up. Your positive feedback is very valuable to us. As indicated earlier, if you have any questions or comments, just put it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel and hit the notification button so that you can get notified of future uploads. We upload videos to our page on a weekly basis. For more support resources, games, and tools to help you master mathematics, do visit our website at Mathgotserved.com or take a look at the links in the description below. Thanks again for watching and have a wonderful day. Goodbye.